Install the Electrical and Electronics Engineering Android app from the link in the comment section below. Also, don't forget to like, share and subscribe to this channel. In this video, we will see an example on phasors. Question: obtain the sinusoids corresponding to each of the following phasors. So here we have to convert these phasors into its equivalent sinusoids. Solution: first of all, we will solve this problem. Now here V1 is given. V1 is equal to 60 at an angle 15 degree volts, and omega is the angular frequency. It is equal to 1. Its unit will be radian per second. Now here V1 is equal to Vm at an angle phi. So this is the standard form of phasor, and V1, small v1 is equal to Vm cos omega t plus phi. So this is the time domain format, and this is called as frequency domain format. So now V1 is equal to Vm value here is 60 cos omega. Omega is the angular frequency and it is equal to 1. So 1 means only we can write t here plus phi. So this is the final answer in sinusoids. This is called as time domain format. Then next problem is problem B. So let's copy this problem from here first. Now here it is given in rectangular form. So we have to convert rectangular to polar form. Now let's convert. If V is equal to, or we can write, we know that complex number Z is the complex number and it is equal to X plus JY. This is called as rectangular form. And Z is equal to R at an angle phi. This is called as polar form. So we have to convert from rectangular form to polar form. So we need R, and R is equal to under root of x square plus y square, and this phi is equal to tan inverse of y by x. So here V2 is equal to V2 is equal to 6 plus J8. So here this is the value of x and this is the value of y. We need in this form R at an angle phi. So the value of R will be under root of x square plus y square at an angle tan inverse of y by x. Now here x value is 6, so 6 square plus y value is 8, so 8 square at an angle tan inverse of 8 by 6. So under root of 6 square plus 8 square, 6 square plus 8 square, it is equal to 10. 10 at an angle tan inverse of 8 by 6. So it is 53.13 degree. So this is the value of V2 in polar form. If we compare this with standard equation, so it will be V is equal to Vm at an angle phi. This is the frequency domain, and small v is equal to Vm cos omega t plus phi. This is the time domain format. So therefore V2 is equal to, small v2 is equal to, Vm value is 10 cos omega value is, here we can see the value of omega is given, it is 40. So 40t plus phi. So this is the phi, means the value of phi is 53.13 degree. Here also for problem 1, here we can see the value of phi is 15 degree. So we have to correct this. It is 15 degree. Now this problem is correct for problem A. Then for this it is 53.13 degree. Now this problem is correct. We can square this, like can make a box like this. Then for this is correct. Next is problem C. So let's see this problem. Now here this can be written as I1 is equal to 2.8 in bracket cos, this e to the power minus j pi by 3 can be written as cos pi by 3. Then here it is minus, so minus j sin pi by 3. So I1 is equal to 2.8 into cos pi by 3 means 180 by 3. You can write directly. So 180 by 3 minus I sin I into sin, again 180 divided by 3, bracket close. So it is 1.4 minus 2.42 j. Now again we will convert this rectangular form to polar form. So let's convert it. So it will be I is equal to under root of, we need this in this form, r at an angle phi, or we can write Im at an angle phi. We need this in this form. So I1 will be equal to under root of 1.4 square plus minus 2.42 square at an angle tan inverse of minus 2.42 divided by 1.4. So this is equal to under root of 1.4 square plus in bracket minus 2.42 square. So it is 2.79 at an angle tan inverse of minus 2.42 divided by 1.4. So it is minus 59.95, that is equal to minus 60 degree. Can write. Now we got this in this form, and we know that I1 or I is equal to Im at an angle phi. we need this in this form, time domain format. This is called as phasor domain format, and in time domain it will be Im cos omega t plus phi. So I1 is equal to, Im value is 2.79 at an angle, not at an angle, it will be cos omega value is, here we can see the value of omega is 377. So 377 plus 377t plus phi value is minus 60 degree. So minus 60 degree here. So this is the value in time domain format or in sinusoidal form. Then next is problem D. Now we have to solve this problem D. So let's copy this from here first. Solution. So here we can see again this is given in rectangular form, and here the real part is negative. So let's see what we have to do now. I2 is equal to minus 0.5 minus j 1.2 ampere, or here we can directly convert it. So let's convert this into its equivalent polar form. It will be under root of minus 0.5 square plus minus 1.2 square at an angle tan inverse of minus 1.2 divided by minus 0.5. Now here we can see when the real part is negative, that time we have to add 180 degree to it. So now this will be under root of minus 0.5 square plus in bracket minus 1.2 square. So it is 1.3. So 1.3 at an angle tan inverse of minus 1.2 divided by minus 0.5. So it is 67.38. Also we have to add 180 degree to it. So plus 180 degree here directly. So it is 247.38. 247.38 degree. Now this is I2 in polar form, and its unit will be ampere obviously. And we know that I is equal to Im at an angle phi. We need this in this form. I is equal to Im cos omega t plus phi. So this is I2. So small I2 is equal to Im value is 1.3, cos omega value is 10 cube. So 10 cube t plus phi value is 247.38 degree, and its unit will be ampere. So this is the final answer in time domain format. So this is how we can convert from phasors to sinusoids. Don't forget to like, share and subscribe to this channel, and thanks for watching.